Okay, dear students, I am going to talk about reverberation, how the reverberation happens in a building. You see, this is a sound phenomenon, reverberation. I will be talking about how it happens in a building, so that you can understand about that. In case of reverberation, generally, there is formation of original sound and the sound goes to the whole room. That gets reflected in the whole room, and after reflection it comes back to the listener. मतलब कोई बिल्डिंग में कोई आपको गाना सुना रहा है, फॉर एग्जाम्पल, नाउ इन ए रूम व्हेन ही इज सिंगिंग ए सॉन्ग, the sound of his singing goes to the whole room, gets reflected through the walls, ceilings, all these things, and comes back to you as a listener. But the thing is that as a listener, the reflection sound will die after some time. The reflection sound which has become reflected in the ceilings, in the walls, in the floor, and coming back to you, undergoes many reflections within the room, and then it dies after some time. As the sound dies after some time, as a result of that, you hear the original sound which still persists. That phenomenon is called reverberation. Means the reflected sound dies earlier, and earlier the reflected sound dies, better is the reverberation. Reverberation effect is best understood in big symphony halls, big auditoriums, wherever a big concert is taking place. Reverberation plays a very good role in case of a concert hall, symphony hall, etc., where a good concert is taking place. You listen the sounds nicely in the reverberation hall. In case of a concert, because of the reflection and its dying down. Now, how we provide with the better reverberation? We provide with better reverberation providing sound absorbing materials. Sound absorbing materials. We provide sound absorbing materials in different parts of the ceiling, wall, and other parts of the room. As a result of what happens, the sound which is coming from the singer or from the originator, it goes to those absorption materials, get absorbed in them, and does not reflect back easily. So what happens? The sound gets absorbed, but the original sound reverberates to the whole room. This absorption can be done with the help of fiberglass and such other materials. जो materials खोखला होते हैं, उनमें absorption बेहतर होता है. We provide such materials which are having holes within them. What happens? Such materials, these are the materials. These are the materials. These are different materials. These are different materials. And we are providing different holes in them. Through this, the sound enters inside to the holes. These are the like sponge, like fiberglass. They are having holes within them. Through the holes, the sounds enter inside. As the sounds enter inside, it's an energy, and energy cannot be created or destroyed. It can be converted from one form to another. Taking that into consideration, the sound energy gets absorbed in the material within and gets converted into heat energy. As a result, what happens? When you stand near the sound originating medium, you will see if you touch the wall or the absorbing materials after some time, you will find the material is heated. The sound energy gets converted into heat energy. And because it gets converted into heat energy, as a result of that, the sound effect, the reflection sound gets destroyed. But the original sound of the singer still then persists. Reverberation is designed in big auditoriums in a big way. In case of auditoriums, reverberation is designed in a better way so that you can get a proper reverberation time. With a good reverberation, the sound effect becomes so good. As a result of that, you find a proper symphony sound or something like that. Especially in case of philharmonic orchestra, in case of symphony sound, in case of violin, reverberation plays a very good role. This is particular types of sounds where the reverberation is very good for the whole auditorium hall in general. Now, reverberation advantages. If I talk of advantages of reverberation, reverberation has got great advantages. One advantage is that it gives a better and smoother sound to your ear. You discern it nicely. That is the main advantage of reverberation. Now, disadvantage. Disadvantage is that if the reflection is totally absorbed in the absorption material of the walls and ceilings, then the original sound may die earlier. There should be some reflection of the sound within the room. ऐसा नहीं है कि पूरा reflection destroy हो जाए. उस केस में reverberation अच्छा नहीं होता. So there should be some amount of reflection within the room, as a result of which reverberation is there. So some amount of reflection along with the absorption, to which the original sound still persists of the dying of the sound of the reflected sound, is the reverberation, and these are the advantages and disadvantages of reverberation. The phenomenon of reverberation is used to enhance the sound quality. So, to reduce reverberation, in case of a room where reverberation is very high, to reduce reverberation, we provide absorption materials within the room. If you provide absorption materials within the room, the reverberation gets lesser in quantity. More absorption material means less reflection, and less reflection means reverberation effect becomes higher. You hear the original sound in a better way if the reflection is absorbed to a large extent. Then, after reverberation, there is another phenomenon. We are talking about different phenomena of sound which are very important for understanding the physics of sound. After reverberation, there is another phenomenon that is called echo. The difference between echo and reverberation is that in case of an echo, it happens in a larger distance. In case of reverberation, it happens in a smaller distance. Another thing, in case of an echo, it gives an unpleasant experience in a symphony hall or an auditorium. But in case of a reverberation properly managed, it gives a soothing effect to the sound in case of materials like philharmonic orchestra or in case of violin. In case of echo, the sound produced by a human being moves like that, and then gets reflected and comes back like that. It moves like that. From the sound, it goes back like that. This is the sound which is going this way. This is the sound which is reflected and coming back. This is echo. The echo effect you understand more in case of a mountain. You go to a mountain, a big hall which is vacant, and you make a sound, large sound. You will find echo over there. But in case of an echo, the original sound does not persist. Original sound does not persist. You will only listen the reflected sound. In case of reverberation, the original sound persists even after the reflected sound dies down. These are the basic differences between the echo and reverberation. Now, I'll talk about basic requirements for good acoustics. Basic requirements for good acoustics. Now, for basic requirements of good acoustics. When we want a good acoustics, there are certain basic requirements of the sound. These are the basic requirements of the sound. Quality of sound remains unchanged. That means within the room where the sound effect is happening, the quality should remain unchanged in different parts of the room. That means the sound should be moving uniformly towards the whole room. I told you the sound moves in a wave-like pattern. And in the wave-like pattern, it should move towards the whole room and cover the whole room. That is what the sound will be doing. The sound produced should be sufficiently loud. The sound should be sufficiently loud so that everybody can listen the sound, whoever present in the hall. A minimum sound a small amount of sound doesn't give a good listening effect. You don't understand the tune or the song, the wordings of the song in that case. No echo. There should not be any echo in the system. Just now I defined echo, it is reflection of sound. There should not be reflection of sound like echo. But there should be proper reverberation. Reverberation should be controlled. That means there should be reflection of the sound, but that reflection should die down, and even then the original sound should persist. We can do it by properly designing the hall with the help of good acoustic lining and etc. No focusing of sound. Sound should not be focused or concentrated in any particular part of the hall. That's very important. In case of a sound, it gets focused in particular part of the hall. The sound gets concentrated in a place. It especially happens when there are uneven corners in the room. If rooms are provided with uneven corners, then there is accumulation of sound in particular corner. So it is to be taken care the room is uniformly square or uniformly rectangular. So there is no uneven corners in the room. No external noise in the hall. There should not be coming any external sound to the hall from outside. All the external sound should be blocked. There should not be external sound from outside within the room. The external sound should be totally blocked. That's what is very important in case of a proper sound. Now, sound absorbing materials. We will be talking about sound absorbing materials. These are different basic requirements of good acoustics. Now we will be talking about sound absorbing materials. Now, these are different sound absorbing materials. We have taken different sound absorbing materials like porous materials, panel absorbers, resonators. These are different sound absorbing materials. Now, the first one, the porous materials. These are the materials which are having small pores within them. Pores means small holes within them. So that the sound gets entered within the holes and does not come out, get absorbed inside. So these are porous materials. These are good sound absorbing materials like wood, fiberglass, wool. Wood matlab lakdi, you know that is the porous material. Fiberglass generally used in insulation, and wool, woolen material you generally wear in the winter, woolen garments. These are good porous materials which absorb sound sufficiently. Then comes panel absorber. Wood on a frame. I take wood, put it on a frame and put on the surface of the wall. Lots of wood are put on a frame and put on the surface of the walls of the symphony hall or the orchestra room or the auditorium. As a result of putting these materials in the wall, it absorbs the sound to a large extent. This helps in absorbing the sound and providing proper effect in the absorption. Then comes resonators. Resonators are specially designed sound materials. There is a special type of resonator which are in the shape of a bottle, like this. Through this the sound enters inside, gets reflected within the surface and then gets decayed. It comes within the surface, gets reflected and then gets decayed as a result. As the sound enters inside, like a bottle, Helmholtz bottle. This is a bottle shaped structure through which the sound is entering inside, getting reflected and dying down continuously. This Helmholtz resonator is a very popular one within the resonators. This is simply a bottle-like structure. You can see it is a bottle having a small inlet, and through the inlet as it enters outside, it's a big surface inside. In that surface it gets reflected and continuously reflected and dies down within that. These are different sound absorbing materials. You have to remember this. These are different sound absorbing materials. What are the sound absorbing materials? Porous materials like wood, fiberglass, wool, panel absorbers like wood on a frame, and resonators like bottle type Helmholtz resonator. These are different types of matters which are to be held inside. Then we come to sound absorbing materials. Sound absorbing materials. After sound absorbing materials, we will come to factors affecting the architectural acoustics. Factors affecting the architectural acoustics. Let me come into that. We are coming to architectural acoustics. Factors affecting architectural acoustics. we'll be talking about. In case of architectural acoustics, we have reverberation time, focusing of sound wave, adequate loudness. Reverberation time takes a very important role within a hall. If the reverberation time is too long, the sound dies. You don't get the feel of the original sound. If it is too short, then the reflection of the sound overwhelms the original sound, and you don't listen the original sound. So the time of reverberation plays a very important role in designing a sound hall. It's a sound design engineer who designs in such a way that the proper execution of the timing happens, execution of the timing of the reverberation happens within the room. Focusing of sound wave. The sound wave should not be focused on a particular corner, that I have already said. It should be focused throughout the whole audience. That means there should be uniform focus of the sound within the room where the people are listening to. And adequate loudness. The sound should be loud enough. That is, the mic and other systems should be loud enough to have a proper sound. You have seen in case of a hall, a good singer before performing tests the sound again and again. Before performing, he comes to the room, tests with the mic, talks in the mic, makes different sounds, and then sees, he finds the reverberation of the sound. He doesn't know the word reverberation, but he knows that is the reverberation which provides a better sound effect within the audience. So a good singer always checks the sound effect within the room. But the sound effect are as described in the whole structure as I have told you. These are the acoustic sound, this architectural acoustics of the sound. Without proper designing of a sound hall, you cannot perform a good program. Any good auditorium, any good cinema hall, any good symphony hall, any good orchestra hall will be having a proper designing of sound system, so that you can listen the sound for the pleasure of the viewers and the listeners. This is what is very important. You, as the interior decorator, whenever designing a sound room, you must take care that proper absorbers are placed, proper loudness of the sound is there is no focusing of the sound, and the room is uniformly shaped. There is no special corner provided within the room. What I mean to say, if the room is like that, if the room is like that, if the room is like that, and here is the stage, and from the stage it goes here, there is a special corner. Here is the concentration of the sound. Here is the concentration of the sound. This is a big problem. So this is what you have to take care of while performing with the sound. Thank you, students, for listening with concentration. Thanks.